Hi, I am Professor DK Panda from the Ohio State University. Together with my colleagues Nauras and Jenghan, we bring you this exciting tutorial to be offered at Supercomputing 2026. The tutorial is titled Principles and Practice of Scalable and Distributed AI Training and Inference. As you know, we are in the field of very exciting field of AI, which comprises of many subfields, especially in this case the machine learning and deep learning, and uh, and in that context, we are going through a lots of rapid changes, not only on the system side but algorithm side and also on the application side, trying to see how this AI field can actually have an impact on a lot of different disciplines. So this is the field of AI, or especially machine learning, deep learning has been there in the field for many, many years. As you can see, like it has been there for hundreds of years. People have been talking about this, but especially in the last 10 years, a lot of changes are happening. And those things are happening especially in the context of newer CPU, GPU, newer interconnects, newer kinds of system integration, and then the software innovations. And all these things being put together, we are leading into the next phase of the AI. So in this context, there is of course the main thing is to have really training. Once you have a lot of data, how do you actually build an AI model? And as the data sizes are increasing, the model sizes are also continuously increasing. You must have heard of or used even ChatGPT and all the related models, the Llama, O2, O3, all these are coming up. But the main thing is that when you try to build this kind of a model or do the take care of the training, especially with huge amount of data, a single GPU is not sufficient. So in that context, you have to use hundreds and thousands of GPUs for many months to really build this model. And this is the very hardcore problem the community is trying to solve, which is called the parallel and distributed training. And especially you in that context, multiple issues come up like how do you build this system, how do you integrate like scale up technologies, scale out technologies, building the collectives, communication libraries, overlapping the computation with communication. All aspects of parallelism and distributed computing actually needs to be totally enhanced and integrated together to solve these kind of problems. Now, of course, now we are in a Gen AI world. So it is not just the training, but using the models, how we can actually use, let's say, LLMs and with inferencing, following an iterative loop, which we can actually generate tokens or words and is fed back to the input for the next. And through these, we are trying to do online LLM inferencing. And of course, there are a lot of metrics here like latency. There are concepts of efficient batch processing, mixed precision support, and of course, under the hood, we need to make sure that these things are also running on systems with high performance interconnects and high memory bandwidth. As you can see, the GPUs are getting very important in the context of these AI machines. As you can see here from the latest June 2026 top 500 list, there are 272 out of the 500 top HPC systems are actually using accelerators or co-processors. And many of the systems are actually, if you see in the number 2, number 3, number 4 in the top 500 list, using different kinds of GPUs from NVIDIA and AMD. And at the same time, domain specific accelerators for also the deep neural network trainings are also emerging. So in that context, if you are a person working in this area or if you are a person interested in working in the area, you will have a lot of questions. For example, like how to understand the DNA training or inference performance in a holistic way, how to correlate low level performance to high level metrics. Question comes, do you need like a dedicated collective communication libraries, or the commonly used MPI, which is message passing interface runtime, is good enough to take care of the training and inferencing? And especially as the model sizes are becoming larger, you may not be able to fit them within a GPU. So then how do you handle out of core DNA training? And And in this context, there are a lot of open issues at the intersection of DL and HPC. And you might have a lot of questions saying how your work actually will be helping in that context. And especially the GPU, modern GPU architectures, the way they are programmed, how to exploit them for both machine learning and deep learning, and also like how to design distributed training frameworks for ML. So these are just a sample of questions, but you might be having many more questions on your mind, especially looking at this field. So to broadly put all together, the broad challenge the field is going or the community is trying to exploit HPC and trying to see how to efficiently scale out both machine learning and deep learning frameworks and take advantage of the heterogeneous high performance computing or the HPC resources. So when we say heterogeneous, these are the CPUs, GPUs, DPU, IPUs, XPUs. A lot of these units are being designed over the years. So we have a very exciting tutorial here. As you can see from the outline, we'll start with a very high level concepts of the AI and HPC convergence, try to introduce different definitions. We'll actually go over the system aware AI lifecycle and HPC stack. Like that means including like a training, inferencing, fine tuning, the Gen AI, hyperparameter optimization, etc. And then we'll try to go over a set of issues like the challenges in exploiting HPC technologies for AI. We'll take a look at some of the modern HPC architectures for AI. Then we'll go into the foundations of deep neural networks, what has happened over the years, the evolution of the deep learning models, and then we'll start with some basic principles and parallelism strategies for the data parallel deep learning training. We have two excellent hands-on exercises here on a GPU cluster. We'll try to see how to do data parallelism training with a standard library like Nickel. At the same time, we'll also try to see how to achieve this through MPI, which is the message passing interface library. After that, we'll go into advanced parallelism strategies, focusing on hybrid parallelism techniques. We'll also take a look at several case studies and solutions. And we also have an exciting lab uh, where you can actually carry out hands-on exercises using hybrid parallelism. And after we have a very good understanding of the training, we'll move to inference. We'll talk about inference scenario and challenges. We'll also have an associated hands-on exercise for distributed inference. And towards the end, we'll talk about the hyperparameter optimization. How do you really optimize the different parameters, especially the hyperparameters in a model? And we'll have an associated hands-on exercises. And at the end, we'll cover some of the open issues and challenges and conclude. So as you can see, we have a lot of exciting materials to present to you, and we look forward to seeing you at the SC. Please take a look at the SC program, and you will see the exact day and the time of the offering. This is a full day tutorial, and we look forward to seeing you and interacting with you. Thank you.